Just how safe is your code? And how can you produce code that is more robust and more resistant to hacking? This tutorial will introduce you to techniques for producing more secure code and to the tools that will help you find flaws in your code. We all know that the internet is a dangerous place and that cyber attacks are frequent and damaging to the availability of our systems, the privacy of our data, and the integrity of our results. While security often focuses on our networks and system configurations, securing these is not enough. Every software service that you develop and deploy is a window into your data center from the outside world, and a window that could be exploited by an attacker. So, is this a problem that we should care about in the high-performance computing world? There are some very good reasons for you to answer yes to this question. Often in the HPC world, we deploy our software as a service, whether it has a web or custom interface, and such services are exposed to attack from anywhere. Or maybe you're deploying a shared data repository. These are becoming much more common as we collect and share large bodies of scientific data. And we're sharing more than data. We're sharing execution cycles. These distributed scheduling and execution environments are exposed to attack. We're also sharing our sensors and instruments as distributed data sources. These sources might be on every street corner or from a few large facilities. And perhaps the most modest of scenarios is the scientists running their own code on their own laptop. What could go wrong here? Well, if you import a dataset from a colleague or remote site, that dataset could contain an attack that would take over your computer. And all too common these days, the bad guys don't even have to steal something. They just have to prevent you from getting your work done. Just the smallest weakness in your code can let the bad guys in. So, this tutorial will get you started on building software with better defenses. The tutorial will start with some basic vocabulary, presenting terms that will help you focus on the key concepts being taught. We will continue by learning how to think like an attacker to get you in the right mindset, and then talk about some all too common software vulnerabilities. Next, we'll talk about automated assessment tools, that is, scanning tools that are available to help find flaws in your code. We'll introduce you to the different types of assessment tools, how these tools work, and their output and limitations. We'll also show how you can use and benefit from the Software Assurance Marketplace, the SWAMP, an open facility that allows you to scan your software with a wide variety of tools without the burden of dealing with tool acquisition, installation, or configuration. In the SWAMP, you can access both commercial and open source software assessment tools. The last part of the tutorial will be devoted to hands-on exercises. You'll get the chance to exploit two types of vulnerabilities in sample programs, identify where in the code the vulnerabilities are, and finally learn how to mitigate them. For these exercises, you'll get to use several automated assessment tools, both open source and commercial, accessible through the SWAMP. These software assurance tools, tools that scan the source or binary code of a program to find weaknesses, are your first line of defense in software security. These tools can catch flaws in a program that affect both correctness and safety of the code. We think that it's a key skill for every programmer. So, join us for an interactive and hands-on session that'll help you up your game in software security.